153 billion miles, that is the almost unbelievable distance that Voyager 1 has put between itself and the Sun since its launch in 1977. To truly grasp the enormity of this distance, consider that it is roughly equivalent to traveling around the Earth 6 million times, or making the trip to Mars and back nearly 500 times. This staggering separation not only highlights the probe's remarkable journey but also serves as a testament to humanity's ability to explore and understand the vastness of space. No other man-made object has ventured so far into the depths of space. Even though this old probe has passed beyond the boundaries of our solar system, it continues its journey undeterred. However, as with all great space missions, a fundamental question arises: how long can Voyager 1 continue its flight before it runs out of power, or we lose contact with it forever? And then, of course, there is the world-famous image taken in 1990, showing our Earth as a pale blue dot from a distance of 6 billion kilometers. But what would we actually see if we were to turn on Voyager's camera today? When Voyager 1 set out into the vastness of space on September 5, 1977, no one could have predicted that it would become one of the greatest success stories in space exploration. Initially, the lifespan of the identical Voyager probes was estimated to be just 5 years. Their primary mission was to gather data about the outer planets of the solar system, which had been little explored until then. But after Voyager 1 had fulfilled its initial objectives by examining Jupiter, Saturn, Uranus, and Neptune, NASA made a pivotal decision: to extend its mission and send it toward the edge of our solar system. The spacecraft has been racing through space at a speed of about 61,000 km per hour ever since. To put this into perspective, the muzzle velocity of a pistol bullet is only 1,260 km per hour. Despite its breakneck speed, Voyager 1 did not reach the heliopause, the outer boundary of the heliosphere, until August 2012. Beyond this zone lies interstellar space, a realm where the influence of the Sun's solar wind ends. Maintaining contact with Voyager 1 is no simple task. At the time of writing, the spacecraft's journey has lasted over 17,280 days, covering a distance of 24.77 billion kilometers, or 165.61 astronomical units, from the Sun. To grasp this scale, consider that the astronomical unit, AU, is the average distance between the Earth and the Sun, about 150 million kilometers. Voyager 1's current distance from the Sun is 4 times the distance between the Sun and Pluto. Communication with the spacecraft involves an incredible delay. A signal sent from Earth takes around 23 hours to reach Voyager 1, and another 23 hours for the response to return. NASA uses the Deep Space Network, a global system of radio antennas, to keep this cosmic long-distance relationship alive. These antennas, including massive 70-meter dishes, have been continuously upgraded to accommodate the Voyager mission. However, as the spacecraft moves farther away, maintaining contact will eventually become impossible. Experts estimate that this final radio blackout could occur by the mid-2030s. Even after losing contact, Voyager 1's journey will continue into interstellar space, carrying a special payload, the Voyager Golden Record. This data plate contains images and audio recordings designed to represent humanity and Earth to any extraterrestrial civilization that might discover it. With an estimated lifespan of 500 million years, this message in a bottle will outlive the human era. The renowned physicist Stephen Hawking once warned that openly revealing our existence and location to potential alien civilizations might not be the wisest idea. However, Voyager 1's golden record represents a bold leap of faith, showcasing humanity's desire to connect with the unknown. Voyager 1 will likely enter the Oort cloud, a vast, spherical shell of icy objects that marks the edge of our Sun's influence, in about 300 years. This region, thought to be a reservoir for long-period comets, stretches from roughly 2,000 to 100,000 astronomical units from the Sun. To put that into perspective, the Earth is just 1 astronomical unit away from the Sun, making the Oort cloud an almost incomprehensibly distant frontier. Its sheer scale and role in shaping our understanding of the solar system's boundaries highlight the incredible achievement of Voyager 1 reaching this far-flung region. It will take another 30,000 years to traverse this region. Beyond the Oort cloud, Voyager 1 will continue its silent voyage through the galaxy, bearing witness to the cosmos as a testament to human ingenuity. Amidst the countless stars outside our galaxy, one stands out as truly unique, a red giant star known as WG64, located about 160,000 light-years away in the Large Magellanic Cloud, LMC. This neighboring galaxy, home to about 30 billion stars, has accompanied our Milky Way for billions of years. The LMC's irregular shape suggests it has undergone significant interactions with the Milky Way and the Small Magellanic Cloud, possibly setting the stage for future mergers. WG64, often referred to as Behemoth, is a red giant at the end of its life, yet it stands out even among its cosmic peers. Unlike other red giants, WG64 exhibits an unusual egg-shaped ring of ejected material and dimming light, phenomena that are not fully understood and challenge existing scientific models. This unique combination of traits has made it a focal point for astronomers seeking to uncover the mysteries of stellar evolution. This star is a scientific marvel, boasting a size 2,000 times larger than our Sun. Red giants are common in the universe, yet WG64's characteristics make it a standout. Its sheer size and the violent processes on its surface have captivated astronomers, who have named it Behemoth in reference to the biblical creature described in the Book of Job. As red giants expand, they often engulf nearby planets. If WG64 once hosted planets, they would have been consumed during its transformation into a red giant. This process offers a glimpse into the future of our own Sun, which is expected to become a red giant in about 4.5 billion years. WG64 is already shedding its outer layers, creating an egg-shaped ring of ejected material visible in recent images. This unique structure has baffled scientists, as no computer model has been able to fully explain its formation. The star's light has also dimmed over the past decade, prompting researchers to study it more closely. These observations suggest that WG64 may be approaching its explosive end as a supernova. The first close-up image of WG64 was made possible by gravity as an advanced tool that works like combining the power of several telescopes to act as one super telescope. Imagine trying to see the details on a butterfly's wing from the Moon. Gravity allows scientists to achieve a similar level of precision. By combining the light from multiple telescopes at the Very Large Telescope Interferometer, VLTI, in Chile, gravity creates incredibly detailed images of stars like WG64, uncovering their secrets like never before. The VLTI combines the power of multiple telescopes to create a virtual telescope with a diameter of up to 200 meters. This unprecedented resolution allows astronomers to observe distant stars with extraordinary precision. Using gravity, researchers have been able to analyze WG64 in real time, breaking down each pixel of the image into hundreds of data points. This technology has revealed astonishing details about the star's surface and the forces shaping its unique structure. These insights not only deepen our understanding of red giants but also pave the way for future studies of distant stars and galaxies. The story of WG64 is a reminder of the dynamic and often violent nature of the universe. From its immense size to its impending supernova, this red giant embodies the epic scale of cosmic evolution. As scientists continue to study WG64 and other stars like it, they unravel the mysteries of stellar life cycles and the forces that shape our universe. Please like, share, subscribe and comment. Thank you for watching my channel.